Hi guys, it's Miss Griffin again. As you can tell, I have a cold. My voice is actually currently better than Miss Wesley's voice, I think, which is why I'm recording another video for you, so you get to listen to me yet again. We're looking at scale factor and ratio today, so our essential question says, how can we calculate the scale factor, or ratio, that maps one figure onto another? We do need to define some of these words that you're seeing in the essential question, but also at the top of your paper, such as scale factor and ratio. Similar triangles are related to one another by something called a scale factor. This is also called the ratio of corresponding sides. If you have a highlighter, I suggest that you grab it, take it out, and highlight some of these words here. Scale factor, ratio of corresponding sides. And the ratios of corresponding sides are equal, which makes sense. If you dilate a figure by a scale factor of 2, then all of the sides are going to scale up by 2, so the ratios are the same. So here, for scale factor off to the side, we're just going to write that we find it by doing new over old. So the new value over the old value, whatever it happens to be. And a ratio is a fraction that expresses a comparison such as A to B. Again, that's a comparison such as, and I want you to grab a highlighter when you're ready for this, A to B. Now, A to B can be written in several different ways. You see it written in words there, but it can also be written like this with a colon, A colon B. It still means A to B. And a third way would be to change it into the fraction form, which you're going to be seeing a lot, A over B. So as we write ratios, we actually write the first expression first. So we have A to B, A to B, A over B. Sorry about the dark highlighting. I didn't have a yellow color available yet. So again, ratios, we go first over second when we write it as fractions, but scale factor is new over old. We're going to see that in a couple different ways in these next few examples. It says in the diagram below, triangle ABC is the image of triangle DBE after a dilation of 3 halves. So we're dilating by a scale factor of 3 halves, and the big triangle is the image. So we're going to label as new and old. ABC is the image, so that means it's new. And DBE must therefore be old. And it says write a ratio, meaning a fraction, to represent each pair of corresponding sides of triangle ABC to triangle DBE. And in addition, state this ratio of lengths. So here, stack your letters. We have A, B, C, D, B, E. So we know that side AB matches with side DB, and we're going to write this as a ratio, and it says of ABC to DBE, so that's why I stacked ABC on top of DBE, because we're going to make our fractions in that same form. Remember, the 2 becomes your colon or your fraction bar, so ABC has to go on top. We'll start with segment AB, matches with segment DB, and this is equal to a different ratio of sides, such as BC and BE. And again, we can see that by looking at our stacked letters. BC matches with BE. And then the third set of corresponding sides, which would be the bases. So AC matches with DE. Notice that I'm using different colors. You can certainly do this as well. Helps you to see those matching parts. Now, they did say to state the ratio of lengths. Our scale factor, remember, is new over old, and that is the scale factor that was given, 3 over 2, sorry. So scale factor is 3 over 2. This is new over old. Essentially, that's how it works. And so then in this case, our ratio of lengths, the sides of triangle ABC to triangle DBE are in a ratio of 3 to 2. It's exactly the same as the scale factor that you just found, which is why we kind of said up above that those words were kind of interchangeable. Scale factor or the ratio of corresponding sides. In example 2, this came from a Common Core exam question. It says, in the diagram below, triangle ABE is the image of triangle ACD after a dilation centered at the origin. So again, ABE is the image, this is the new. ACD was the old. They give us the coordinates, they're already like plotted, so you don't have to worry about plotting. And then it says the ratio of lengths of BE onto CD is blank. We have to choose the correct choice. So when they say BE onto, and they're talking about a ratio, remember BE goes on top of CD. So BE is here, and it's going on top of its corresponding side, CD. Now we do need to list the ratio of other sides because those are diagonals, and it's going to be tough for us to count the length of diagonals. They didn't tell us what the scale factor was. That's what we're going to try to figure out by counting the length of each side. So here, if I'm looking at a different side of the triangle, such as AE, AE is still from triangle ABE, which you can see here. AE corresponds with AD. Or we could talk about the third set of sides. Just like we did up above, BA corresponds with CA. So, like I said, it's hard to count these diagonal distances. And in fact, you have to use Pythagorean theorem to count them. But we can count vertical or horizontal distances. I'm going to simply count vertical because I see that they end at actual values, whereas like C is kind of in between two whole numbers. So it's just easiest for me to count vertically here. AE is 1, 2, 3, 4 boxes tall, and AD is 4, 5, 6 boxes tall. So I know that the ratio of lengths are equal based on a statement up above, because remember, scale factor scales up all of the sides. So we have BE over CD, which is still equal to AE over AD, which we just counted. AE came out to be the value of 4, and AD came out to be the value of 6. Now 4 over 6 is not a choice, clearly. However, 4 over 6 can be reduced. You can either type it into your calculator, hit enter, or just do it in your head. Divide the top and the bottom by something in common, such as 2. This brings us down to 2/3. 2/3, 2/3. So again, if you can't find the ratio of the given lengths that they're asking for, find the ratio of other lengths because they should be the same. We could have counted CA and BA and found the same exact answer if we reduced. All right, flip it over. We got another question or two to take a look at. This one again came from a Common Core question. It says the ratio of similarity of triangle boy to triangle girl is 1 to 2. So they go boy onto girl, 1 onto 2. So we're going to stack our letters here. Triangle BOY over triangle GRL. We're going to go 1 over 2. So then they say that BO and GR have these expressions, and we're looking for the length of GR. Well, in the end, that means we need 3x minus 1 because that's what GR is according to the problem. So we know that BO corresponds with GR based on our stacked letters. So we're going to put the expression for BO on top because it comes from boy, and boy was going on to girl. And the expression for girl, GR, on the bottom, 3x minus 1, and it's still equal to 1/2, that ratio of similarity, or in other words, the ratio of corresponding sides, or in other words, the scale factor. All of those phrases are interchangeable, and I know that's frustrating and annoying for you to have to remember all of them, but they all mean the same thing. So now, to solve this, just like we have been with proportions, you just cross multiply. So on this direction, 1 times 3x minus 1, that just gives us 3x minus 1. But in the other direction, 2 times x plus 3, I have to be careful and make sure that I put the x plus 3 in parentheses, because 2 has to get distributed, which I'm going to do right now. So we have 2x plus 6 on the right and 3x minus 1 on the left. Now, if you had already gone ahead and done this, you could have 2x plus 6 on the left, 3x minus 1 on the right. It doesn't matter as long as you are able to solve and get the same answer. So pause the video real quick, solve this for x, and then go back and find the length of GR. And remember that that is 3x minus 1, so you literally just replace the x with whatever we find over here on the right. Alright, so again, pause the video, hit play when you're ready to see final answer. Okay, so for my final answer here, I have x equals 7. So plugging that in for GR, we get 3 times 7 minus 1, which gives us 20. Final answer for the length of GR should be 20. If you take a look down here at example 4, we're taking a look at the relationship between perimeters and areas, and it actually tells you that it's directly related to the scale factor of similar triangles. In the diagram below, we have triangle DEF, which is the image, so you should label this as new. And it's the image of triangle ABC, which is old. After a dilation with a scale factor of 3, using the calculations below, state the relationship between perimeter and areas. And we're relating it back to the scale factor, not to one another, but back to the scale factor. Before we do that, we need to make sure that we both or all understand that perimeter is the outside. And to find it, you have to add all your sides. You may have to do this at some point yourself, not just look at perimeters that are already written out for you or areas. So make sure that you're writing this down so you can always refer back to it. Add all of the sides. Whereas area is the inside of a figure. The space that's taken up on the inside. And so we have different areas. Area of a triangle is equal to base times height divided by 2. Area of a rectangle is just base times height, or length times width is another way you might know it. Area of a circle is pi r squared. That's the basics that you need to know. But today we're taking a look at triangles because we're in the triangle similarity unit. Alright, so we know that we scaled up the sides by a factor of 3. Not only did it state it, but you could actually do the math yourself. 4 times 3 gives you 12. 5 times 3 gave you 15. 3 times 3 gives you 9. Now when we look at the perimeters, they denote it by P of triangle ABC. That means perimeter of triangle ABC is equal to 4 plus 3 plus 5. Take the sides, add them up, and you get 12. Same thing for triangle DEF, except we have 12, 9, 15. That's summed to 36. Think about for a minute, how do you go from 12 to 36 by multiplication? We multiplied here, multiplied here, multiplied here, so we must be multiplying to get the new perimeter. And in fact, we are multiplying by 3. So perimeters use the same scale factor. We're going to write that up here off to the side. Perimeters use scale factor. Not only do they use the scale factor, but we can also say that perimeters, let's stick in there ratio of perimeters, sorry. Ratio of perimeters equals the ratio of corresponding sides. So because the corresponding sides have a ratio that's the same as the scale factor, the ratio of perimeters is also the same. Now let's take a look at the areas. Area, we said base times height, 3 times 4, divided by 2 to get 6. And same thing for triangle DEF, 9 times 12 divided by 2 to give us 54. Now we're thinking, how do we get from 6 to 54? It's clearly not just times 3. Right? 6 times 3 gives you 18. That's not 54. But 6 times something gives us 54. Hopefully you're doing a little bit of math in your head or on your calculator to find out that it's 9. 6 times 9 gives you 54. But notice that 9 has something in common with that scale factor of 3. 3 times itself, or 3 squared, is 9. And so here we know that area uses scale factor squared. Okay, and you can think about it because area is square units anyways. I didn't put units on here, but if you think back to 7th or 8th grade, when you were doing area is always squared units. Like inches squared or centimeters squared, pickle squared, I don't care what it is, but it's always square units. And so here, scale factor must be squared in order to get the proper area of the new image. So I'm going to box this in, but then we're also going to talk about the ratio of areas equals the ratio of corresponding sides squared. So we've just described the relationship between areas, perimeters, scale factor, as well as taking a look at scale factor in regards to sides on triangles, ratios of corresponding sides, things like that. If you need to look back at the video or to rewind a little bit, then please by all means do it. Otherwise, get to work on your practice problems. Don't skip practice because you need it in order to be successful in mastering this material over time. Okay, I'll see you with the next video. Bye.